vocabulary term is a prism. That would be a polyhedron with exactly two congruent parallel bases. The name of the prism comes from the shape of its bases. So down here you can see two examples of prisms. They are polyhedrons because they each are three-dimensional figures that have flat surfaces, and they each have two congruent parallel bases. In our rectangular prism, we have two congruent parallel rectangles. And note, in a rectangular prism, the top and the bottom could be your bases, the left side and the right side could be your bases, the front and the back could be your bases. You have three different pairs of congruent parallel bases that you can choose from in a rectangular prism. It's unique in that way. In a triangular prism, like the one over here, we see that we have, again, all flat surfaces, making it a polyhedron, and we have two congruent parallel bases that are triangles in this case. Please don't assume that the bottom and the top of your three-dimensional figure have to be your base. It's the two congruent parallel shapes. So in this case, those would be triangles. Over here, they would be rectangles. Now let's talk about the lateral faces. So those would be the sides of the polyhedron that are not the bases. So in our examples down here, if we chose in our rectangular prism the top and the bottom to be our bases, then the left, right, front, and back sides would all be considered the lateral faces, the sides that are not the bases. Over here in our triangular prism, since our bases would be these two congruent parallel triangles, that means these three rectangular faces here, the left side, the right side, and the bottom, would all be considered your lateral faces. Now, an altitude would be a perpendicular segment that joins the planes of the bases. Now, we've worked with an altitude before. Remember, altitudes just go from a vertex and they're perpendicular to the opposite side. In a prism, in a right prism, they're going to go from a vertex in one base and be perpendicular to the other base. So in each of these examples, we see that our altitude goes from one base and is perpendicular to the other base. Now, if you recall, the height is just going to be the length of that altitude. So altitude and height we use synonymously in this class. The height is just the length of your altitude, the distance between the two congruent parallel bases. Now let's talk about the lateral area of a prism. So the lateral area of a right prism is the product of the perimeter of the base and the height, or lateral area is equal to P times H. Now remember, a right prism is just going to be a prism where each of the segments connecting the two congruent parallel bases is perpendicular to both bases. Now the lateral area of a prism is just concerned with the area of the lateral faces. So the faces, the sides of your polyhedron that are not the bases. So if you add up the areas of all of these sides that are not your bases, that will give you your lateral area. And the way we find that is by getting the perimeter of one of the bases. So in this case, that would be the measure of segment AB plus the measure of segment BC plus the measure of segment CD plus the measure of segment DA. The perimeter of that base times your height, which in this case would be the measure of segment EA. That will get you your lateral area, the area of all four lateral faces. In our triangular prism over here, if we want to find the lateral area, we would find the perimeter of one of the triangles and then multiply that by the altitude or the height of this prism, which would be the perpendicular distance between the two bases.
Example time, examples all the way.
Now example 1 says find the lateral area of the prisms below. So here we have this prism. Now I want you to assume anytime you get a prism like this, it's going to be a rectangular prism. They're not going to make some of the angles different than any of the other angles. We're going to assume that each of these faces would be rectangles. So in this rectangular prism, how am I going to find the lateral area? Well, remember, to find the lateral area of a prism, that's going to be the perimeter of the base times the height. So in this prism, which of the faces are we going to consider our bases? Well, let's just consider the top and the bottom of this rectangular prism to be our bases. If that's the case, can we find the perimeter of one of the bases? Yeah, since each of these faces are going to be rectangles, we know that opposite sides must be congruent. So if this side is 10 inches, this side must also be 10 inches. If this side is 5 inches, this side must also be 5 inches. So now I can find the perimeter of one of the bases. It's just going to be 10 inches plus 5 inches plus 10 inches plus 5 inches. The height is going to be the perpendicular distance between those two bases, which would be this 4 inches. So we can plug that in there. Now all we have to do is simplify and we get that the lateral area of this rectangular prism is 120 inches squared, or square inches. Notice the square units because we're finding area. Part B, we want to find the lateral area of this triangular prism. So in order to find the lateral area of a prism, we need the lateral area of a prism formula. That would be the perimeter of one of the bases times the height, or the perpendicular distance between the two bases. So in this triangular prism, which of the faces are going to be our bases? That would be these two congruent parallel triangles. So now all I have to do is find the perimeter of one of the bases, which here it gives you, right? 10 feet plus 6 feet plus 6 feet gives you the perimeter of one of your triangular bases. The height is going to be the perpendicular distance between those two bases, which would be this 8 feet right here. So all we have to do is simplify inside the parentheses first and then multiply it, and you get the lateral area of this triangular prism is 176 feet squared, or square feet. Now let's talk about the surface area of a prism. The surface area of a right prism is the sum of the lateral area and the areas of the two bases. So this makes a lot of sense when you think about that surface area is also called total area, and it gives you the area of all of the faces of your polyhedron. So in this case, if we want to find the surface area or total area, we would take the lateral area, which we know how to find now, the perimeter of one of the bases times the height, and we would add in the area of the two bases. That would give you the area of all of the faces of your prism added together. So in this rectangular prism, if I wanted to find the surface area, I would take the lateral area, which would be the perimeter of one of the bases, times the height, the perpendicular distance between the two bases, and then add in 2 times the area of one base, because 2 times the area of one base gives you the area of both bases. Same thing over here. If I want to find the surface area or total area of this triangular prism, I would take the lateral area of this triangular prism, which would be the perimeter of one of the bases times the height, and then add in 2 times the area of one of the bases. Now example 2 says find the surface area of the prisms below. So here we have this rectangular prism. Remember, we're considering any prism that looks like this to be a rectangular prism, meaning all the faces here are going to be rectangles. So if I wanted to find the surface area of this rectangular prism, the surface area of a prism formula is equal to the lateral area of that prism plus 2 times the area of one of the bases. Now remember, to find the lateral area in a prism, it's just going to be the perimeter of one of the bases times the height. So in this figure, which of the faces are we going to consider our bases? Well, because it's a rectangular prism, you can consider the top and the bottom to be your bases, the left side and the right side to be your bases, or the front and the back to be your bases. I'm going to consider the top and the bottom to be our bases. When I do that, I can then fill out this formula. I need to find the perimeter of one of the bases. Well, if this base right here is a rectangle, I know opposite sides must be congruent to each other. So I know the perimeter of this base is just going to be 9 meters plus 7 meters plus 9 meters plus 7 meters. The height of this prism is going to be the perpendicular distance between the two bases. That would be this 18 meters. So that's going to go in for H right here. Then it's going to be plus 2 times the area of one of the bases. So if we're considering the top and the bottom to be our bases, we just need to figure out the area of one of those bases. Well, since this is a rectangle, we can just multiply base times height. So 9 meters times 7 meters. That'll give you the area of one of the bases, and then multiply that by 2 to get you the area of both of the bases. So now we multiply each of these and then add them together to get our surface area of this rectangular prism, which is 702 meters squared, or square meters. Part B, we again want to find the surface area, and the surface area of a prism formula is equal to the lateral area of that prism plus 2 times the area of one of the bases. Well, in a prism, the lateral area is equal to the perimeter of one of the bases times the height of your prism. So in this figure, which of the faces are going to be considered our bases? Well, they have to be 2 congruent parallel shapes. So in this case, that would be these 2 congruent parallel triangles. So now that I know those are our bases, I can start filling out this surface area formula. The first thing we need to find would be the perimeter of one of the bases. Well, since these two are our bases, oh, look, it gives us the perimeter of one of our bases. It's going to be 9 centimeters plus 10 centimeters plus 12 centimeters. That was easy. The height is going to be the perpendicular distance between the two bases. So that would be this 25 centimeters. That's going to go in for H. And then plus 2 times the area of one of the bases. Well, since our bases are triangles, remember the area of a triangle formula is 1/2 base times height. So in this figure, we are only given the height of this triangle down here. Well, since they're congruent, we know that's also going to be the height of this triangle up here. And since we know the base of this triangle up here is 12 centimeters, that means the base of this triangle down here is also going to be 12 centimeters. So I can find the area of one of the bases by taking 1/2 and multiplying it by 12, and then multiplying that by 5. That'll give you the area of one of your bases. So now all I have to do is simplify this, multiply these together over here, add them together, and I get that the surface area of this triangular prism is 835 centimeters squared, or square centimeters. Now we're going to talk about a cylinder. So a cylinder is a 3-dimensional figure whose bases are 2 congruent parallel circles. Now it's important to note that a cylinder we're going to treat exactly like a prism, because it technically is a prism. It's just a prism with bases that are circles. And note that this would be considered a right cylinder because the side of your cylinder is perpendicular to each of the bases. And just like in a prism, the altitude is going to be the perpendicular segment that joins the planes of the bases. And in a right cylinder, the altitude you can see on the left side, the right side, or in the center of your cylinder. And note that just like in a prism, the height is going to be the length of your altitude. So whatever that perpendicular distance is between the two bases, that's going to be considered your height. Now, the lateral area of a cylinder is going to be the area of the rectangle formed by unrolling a cylinder. So imagine for a second you have a toilet paper roll in front of you and you cut it along one side and unfold it. It creates a rectangle. So the lateral area of the cylinder is just going to be the area of that rectangle. So in this cylinder right here, we know that the perpendicular distance between our two bases would be the height or the length of that altitude. The perimeter of your base in a cylinder, well, we know that the perimeter of a circle is called the circumference, and the circumference formula is just 2 pi r. So if I were to cut this cylinder along one side and unroll it, it would look something like this. And in this rectangle right here, the height is still going to be your height, and the base is going to be the perimeter of one of your bases, one of your circles over here, which is the circumference, 2 pi r. So again, the lateral area of a cylinder is just the area of the side of your cylinder, which if we were to unravel would be this rectangle right here. Now, the surface area of the cylinder would be the sum of the lateral area and the area of the two circular bases. So if we take the area of that rectangle we just talked about when we unravel a cylinder, and we add that to the area of our two bases, these two circles right here, that will give us the surface area of our cylinder. Remember, the surface area of a cylinder or a prism is just going to be the lateral area of your prism or cylinder plus the area of the two bases. Now let's get a little more in depth in the lateral area of a cylinder. So the lateral area of a right cylinder is the product of the circumference of the base and the height of the cylinder, or lateral area is equal to the perimeter of the base times the height. Now remember, this is the exact same lateral area formula that we had for prisms. The only difference this time is that we have a cylinder, which is a prism with circular bases. So instead of being the perimeter of your base, the perimeter of a circle is the circumference. So we could actually rewrite this lateral area formula for a cylinder as 2 pi r times h, where 2 pi r is just the perimeter or circumference of one of your bases. Now example 3 says find the lateral area of the cylinder below. Round answer to the nearest tenth. So we want to find the lateral area, which would be the area of the side of this given cylinder. So how do we find the lateral area of a cylinder? Well, that formula is the exact same formula as the lateral area of a prism. Lateral area is equal to the perimeter of the base times the height. Only this time, your base is a circle. So the perimeter of your base is going to be the circumference of your circle, which is 2 pi r. So all we need is the radius of your circle and the height of your cylinder. So the radius of our circle here is 2 centimeters. That's going to go in here. The height of your cylinder is going to be the perpendicular distance between our bases, which would be this 10 centimeters right here. That's going to go in there. Now, what you could do here is multiply the 2 pi times the 2, you get 4 pi. Then multiply that 4 pi to the 10, you get 40 pi centimeters squared or square centimeters. That would be the exact lateral area of this cylinder right here. But since it wants your answer rounded to the nearest tenth, you just plug all this in your calculator, round to 1 decimal place, and you get that the lateral area of this right cylinder is approximately equal to 125.7 centimeters squared or square centimeters. Part B, doing the exact same thing. We want to find the lateral area or the area of the side of this cylinder. So the lateral area of a cylinder formula, the same as the lateral area of a prism formula. Lateral area is equal to the perimeter of the base times the height. So the perimeter of your base this time, because your bases are circles, is going to be the circumference of this given circle, which is 2 pi r. So all we need is the radius of one of your bases, and we can multiply that by the perpendicular distance between the bases, your height. So what would be the radius of this circle? Well, since we're given the diameter here is 18 inches, we know the radius is half of that, so that's going to be 9 inches. So we're going to take 9 inches, plug that in for r. The height we said is the perpendicular distance between the bases, which would be this 12 inches, so that goes in for h. Now what you could do is you could take this 2 pi, multiply it to the 9, you get 18 pi. Then take that 18 pi, multiply it to the 12, you get 216 pi inches squared or square inches. That would be the exact lateral area of this cylinder here. But because this question wants you to round your answer to the nearest tenth, you're just going to plug all of this in your calculator, round to 1 decimal place, and you get the lateral area of this cylinder is approximately equal to 678.6 inches squared or square inches. Now let's talk about the surface area of a cylinder. So the surface area of a right cylinder is the sum of the lateral area and the area of the two bases. So just like the surface area formula for a prism, the surface area formula for a cylinder is surface area is equal to the lateral area plus 2 times the area of a base. The only difference this time is that in a cylinder, your bases are circles. So we could rewrite this surface area formula as the surface area is equal to the lateral area, which is the perimeter of your base times your height, or the circumference times your height, so 2 pi r times h, plus 2 times the area of a base, which in this case is a circle, so that would be pi r squared. That is the surface area of a cylinder formula. Now example 4 says find the surface area of the cylinder below. Round answer to the nearest tenth. So we want to find the surface area of this cylinder. So we need to remember the surface area of a cylinder formula. What is the surface area of a cylinder? Surface area is equal to the lateral area plus 2 times the area of a base. And we know in this cylinder, our bases are going to be the two congruent parallel circles. So if we want to find the lateral area, remember lateral area of a prism or a cylinder is just the perimeter of one of the bases times the height. So the perimeter of our base here would be the circumference of one of our circles, or 2 pi r. And if we take that and multiply it by the height of our cylinder, we end up getting the lateral area of our cylinder. But because we're finding the surface area, we need to add 2 times the area of a base. And because our bases are circles, the area of a base formula would be pi r squared. So how do we find the radius of one of our bases? Well, since it gives us the diameter, we just take that diameter, divide it by 2, and we get that the radius of one of our bases is going to be 3 centimeters. So that's going to go in here and here. The height of our prism is going to be the perpendicular distance between the two bases, which would be this 9 centimeters right here. That goes in there. Now all we have to do is just simplify. Multiply this out, add these two together, and we get that 72 pi centimeters squared, or square centimeters, is the exact surface area of this given cylinder. But because the question wants you to round to the nearest tenth, we're going to multiply 72 times pi in our calculator and round to 1 decimal place. And we get that the surface area of this cylinder is approximately equal to 226.2 centimeters squared, or square centimeters.
I make the best presents, but you can try.
Okay, doing the same thing. We want to find the surface area of this given cylinder. So how do we find the surface area of a cylinder? Well, the surface area of a cylinder formula is the same as the surface area of a prism formula. The surface area is just going to be equal to the lateral area plus 2 times the area of a base. Now, because we're dealing with a cylinder, we know that the bases are going to be these two congruent parallel circles. Meaning, to fill out this surface area formula, we start with our lateral area, which we know the formula for that is the same for a prism or a cylinder. It's the perimeter of one of the bases times the height of your prism. Well, the perimeter of one of the bases would be the circumference of one of the circles, or 2 pi r. Then we multiply that by the height of your prism. That'll give you the lateral area of this cylinder. Now, because this is a cylinder, we know the bases are circles, meaning the area of one of the bases would be pi r squared. Now, it gives us the radius. It's 1.5 meters, so we can plug that in here and here. The height of your prism is the perpendicular distance between your two bases. That's 12 meters. That goes in here. Then all we have to do is just multiply these out, add these together, and we get that the exact surface area of this given cylinder is 40.5 pi meters squared, or square meters. But this question doesn't want the exact surface area. It wants you to round your answer to the nearest tenth. So we multiply 40.5 times pi in our calculator, round to 1 decimal place, and we get that the surface area of this cylinder is approximately equal to 127.2 meters squared, or square meters. Now example 5 says find the surface area of the cylinder below if the area of one base is 25 pi inches squared, or square inches. Round answer to the nearest tenth. So in this example, we're still trying to find the surface area of a cylinder. The only difference this time is that instead of giving us the height of the cylinder and a diameter or radius of one of our bases, it's giving us the height of our cylinder and the area of one of our bases. So if you recall, the two things that we need in order to find the surface area of a cylinder would be the radius of one of the bases and the height of your cylinder. Since we have the height of our cylinder, we just need to find the radius of one of the bases. Well, how do we do that? Well, that's where this area comes in handy. If we know that the area of one of the bases is 25 pi inches squared, we can just plug that in to the area of a circle formula and solve for the radius. So I can take 25 pi, plug that in for our area over here, and solve for r. So how do I solve this for r? Well, I'm going to divide both sides by pi, and I'm going to square root both sides. Now, if you recall, anytime you square root a variable squared, on the other side, when you square root, you have to put a plus or minus. Over here, the square root and the square cancel each other out, and on this side, the square root of 25, we know, is plus or minus 5. Now, because we're dealing with measurements of a cylinder, we can't have a negative radius. So we're just going to take the principal root, the positive version. And we're going to say that r is going to be equal to 5 inches. Now that I know the radius of one of our bases here, I can go about solving for the surface area. And remember, to find the surface area of a cylinder, we need the surface area of a cylinder formula, which is surface area is equal to the lateral area plus 2 times the area of a base. It's just like the surface area formula for a prism. Only this time, our bases are going to be circles. So when we go about filling out the surface area formula, we need to find the lateral area. Remember, lateral area for a prism or a cylinder is going to be equal to the perimeter of one of the bases times the height of your prism or cylinder. In this case, since our base is a circle, the perimeter of your circle is going to be the circumference of the circle, which is 2 pi r, times the height of your prism, which would be h. So 2 pi r times h is going to give you the lateral area of this cylinder. The area of a base, since the bases are circles, is going to be the area of a circle formula, pi r squared. Now, since we know our radius is 5 inches, we can plug that in here and here. Since we know the height of our cylinder is 7 inches, we can plug that in over here. Now, all we have to do is multiply these together, then add those two together, and we get that the exact surface area of this cylinder is equal to 120 pi inches squared, or square inches. But because in this question it wants us to round our answer to the nearest tenth, it doesn't want the exact surface area. What we do is we multiply 120 times pi in our calculator, and we get that the surface area of this cylinder is approximately equal to 377.0 inches squared, or square inches, when we round to the nearest tenth.
Try this and be on the nice list.
Okay, doing the same thing here. We want to find the surface area of this cylinder. And in order to find the surface area of a cylinder, we just showed that you need the radius of one of the bases and you need the height of your cylinder. Well, we are given the height of our cylinder, but we're not given a radius of one of our bases. So that's what we need to find. So how do we find the radius of one of our bases? Well, we're given that the area of one of our bases is 49 pi centimeters squared, or square centimeters. So we can plug that in the area of a circle formula and solve for the radius. So if I were to take this area, 49 pi, plug that in for our area here, I could solve for r. So how do I solve for r? I divide both sides by pi, square root both sides, and remember, anytime you square root a variable squared, on the other side you need to put plus or minus. Over here, the square root and the square cancel each other out. On this side, the square root of 49 is going to be plus or minus 7. But because we're dealing with measurements in a cylinder, you can't have a negative radius. So we're just going to take the positive version, the principal root, and we're going to say r is going to be equal to 7 centimeters. So since we know the radius of one of our bases, we can go ahead and find the surface area of this cylinder. Remember, the surface area of a cylinder formula is going to be surface area is equal to the lateral area of the cylinder plus 2 times the area of a base, just like the surface area formula for a prism. Only this time, our bases are circles. So what we need to do first is fill out our lateral area, which again is the perimeter of a base times the height of your prism. And since our bases are circles, the perimeter is the circumference of the circle. So that would be 2 pi r, and then multiply that by h to get your lateral area. The area of a base, since the bases are circles, is going to be the area of a circle formula, pi r squared. Now all we need to do is plug in what we know. We know that the radius of each of our bases is 7 centimeters. That's going to go in here and here. We know that the height of our cylinder is 9 centimeters. That's going to go in here. We multiply these together, then add those two values together to get the exact surface area of this given cylinder. But since this question doesn't want the exact surface area, it wants you to round to the nearest tenth. You go ahead and multiply 224 times pi in your calculator, round to 1 decimal place, and you get that the surface area of this cylinder is approximately equal to 703.7 centimeters squared, or square centimeters. Now in this chapter, we're going to be learning a lot of new formulas. So here's a formula sheet that you're going to fill out as we go. So far today, we learned the lateral area and surface area formulas for a prism and the lateral and surface area formulas for a cylinder. We're going to learn a lot more as the chapter goes on. So make sure you memorize these.